As we all know, natural disasters can have major impacts on both large and small communities. One such way is by affecting the way we transport both food and emergency supplies. If a community's bridge or way of transportation is destroyed, we need to find a way to transport that supplies to them. Now, with this problem in mind, our group has been tasked with designing a model mechanism that can safely transport an egg across a 4-meter gap and as close to the 8-meter distance as possible. As straightforward as that sounds, it isn't that simple. We were provided numerous constraints that will affect how we approach the problem. To begin with, we analyzed the rules outlined in this challenge, which established both our objectives and constraints. Our design was restricted to using no more than 4 joules of energy to transport the supplies across the canyon area. Additionally, it had to fit within a 1 by 1 by 1 meter operating zone without relying on explosives, pressurized gases, or chemical reactions for activation. We were also tasked with working with a limited budget while ensuring the cargo remained safe and intact. The constraints clearly defined, we shifted our focus to establishing our objectives. This involves identifying how to make the design as optimal as possible. We prioritize simplicity, aesthetics, reusability, accuracy, and minimizing embodied emissions as key factors to guide our approach. To come up with a solution for our problem, we used various ideation techniques such as brainstorming, analogy, inspiration, and research. All of this led to us developing 5 possible design alternatives, which we then evaluated for the best one. These designs were a drone, a trebuchet, a bridge cart, a catapult, and the spring launcher. By using a weighted decision matrix and choosing the best design based on how well it met each of our objectives, we identified our best possible solution as the simple and humble spring launcher. After this monumentous decision, we now had to start the process of designing. Our final design is a spring cannon which utilizes a PVC pipe shaft and a compression spring to launch the egg. There is a base plate and an angle plate which are fastened together using a hinge on one end. The PVC pipe will be put on top of the angle adjusting plate with support walls around it held down by metal straps to support the design. To adjust the angle of our design, we developed a revolutionary design of using a wooden block to specify an angle. To launch the egg, we will pull back the rod at the back of the PVC pipe, which compresses the spring and will launch the egg once it is released. As a result of testing our finished design, we were successfully able to shoot the egg consistently over the 4-meter gap safely without damaging it. It was close to the 8-meter distance throughout the testing, which was an important objective to our group. We faced numerous challenges during the fabrication process, but overcame them to create a final design that achieves the goal we set out to accomplish.